Alright, Evan here. I'm finally back to hopefully finish up this Megasquirt build series. I've been pretty busy with the 3D printer project, and I've also, between the weather being pretty bad, I have actually been working quite a bit on the Eclipse, getting the battery mounted and getting some oil leaks fixed and water leaks fixed and replumbed and heat shields built and all kinds of dumb stuff that's really not Megasquirt related. It's just mostly because the person who did the job in the first place kind of cut some corners, and I'm not sure how long they actually had the turbo on the car because the hot end was just trying to melt my cooling fan and stuff. So um, it was in pretty sad shape, but it's finally come together enough to where I'm driving it back to and from work again, and tuning along the way. So I've made some good advances in my tuning progress that I will hopefully share with you here in the next few videos. So I wanted to first go through my settings here and just walk through what all I've got set up, kind of what it took to get this going. I did start with the SimTech Labs MSQ from their website. They have a repository of MSQs, so I use their kind of base Turbo 420A one, but hopefully you can find an MSQ similar. Just don't rely too much on that. You got to go in and know what all these settings are and what they do. So hopefully I'll run through them real quick and explain what they are. If you're already really familiar um, with all this, my next video hopefully will be in the car and I'll be doing some tuning and stuff. But I'm going to run through pretty much everything I've got set up, and I'll try to be quick about it, but there is a lot here, so bear with me. So under basic setup, we have engine constants. Required fuel is a function of your engine displacement, the number of cylinders, the injector flow, and the air-fuel ratio. So this would be in CC. It loses the values between, this is just a calculator, but it loses the values every time you open it, so it's kind of annoying. But make sure that you get these in the correct units here. So CC per minute is going to be what my injectors are. A lot of the American cars are pounds per hour, but either way, also keep in mind that if you're not running a factory, I think 43.5 is typically what injectors are rated at, but make sure that you don't just put in your flow here if you're running a non-standard fuel pressure. So I've got a regulator off of an old Dodge Turbo car that my friend gave me, and it actually runs at like 58 or 60 psi. So I've went ahead and converted that with some online calculator that made my 560 cc injectors flow more like 663 or so cc per minute, that is. So I've got my speed density algorithm here. That's going to use the manifold air pressure and temperature to figure out how much air is actually in there. It's pretty cool. It's I think it's PV equals NRT is going to be the ideal gas law. I want to say so. Pressure times volume equals N is the number of moles times R, which is the ideal gas constant, and T is the temperature in Kelvin, I believe. Either way, you should look that up because it's kind of cool, but how it all works out. Anyway, so you're looking at the speed density here. This is the way pretty much this car was factory was speed density. So you'll know the difference between speed density and MAF because a MAF, like a lot of the starting with like the LT1 Camaros and stuff like that. I don't know who started it. I think probably the foreign cars, the import cars, but they actually have different types of airflow meters to get the amount of air right from the air flowing by. So there'll be a hot wire that it cools down, or just various other methods. I think there's about 3 different types out there, but we're not using that because I didn't want to rig up a MAF, and speed density is fine. A lot of people use it. Alpha N's often used on drag cars, but I think anything turbo you don't want to use alpha N, I don't think, on. And independent throttle bodies is something else you can get into, but it's got special modes for that because you have trouble getting a vacuum reference off of those. But either way, squirts per cycle, a lot of these, this is just the 420A standard stuff. So I pretty much copied those values, but they do make sense. And keep in mind here, back to that same screen, Megasquirt doesn't know what sort of engine you have. so you have to tell it. It can run a 1-cylinder, it can run a 4 or a 6 or probably a 7 or a 5 or up to a 12, I think, officially, and I think other people have run 16s and so on. So either way, you can run a ton of different stuff with this, so you got to make sure that you define what engine you have. And for the 428, all that info is out there, so just find it and pay attention to what you're putting in, but use the default values that most people will give you. So my injectors are not the factory injectors, and of course if you're turboing your 420A, you probably can't get away with the factory ones anyway. So this is important. I did do low impedance injectors. Mine are out of an Evo 8. They're I think 560cc injectors. I got them for $100 for the whole set, so that's a pretty good deal. And it really doesn't. You don't have to be too particular as long as you have enough fuel headroom. So I may talk about that later, although I think I've already mentioned it in past videos. Check out the fuel injector video if you haven't. I spent a lot of time on talking about fuel injectors on that one. So anyway, this setting here, this is for low impedance injectors. So I'm using a peak and hold on this Megasquirt 2. You won't have this stuff if you have high impedance injectors, which are a lot more common, or people use a resistor box. But I didn't want to source or install a resistor box, so I'm doing this fixing software, which I really like the ability to do. Moving on, more ignition settings. So this is all the advanced use table for advanced prediction, things like that. The dwell of your spark or of your coils, you'll find all that info online for the 420A. For your, if you're doing a non-420A build, just something else you put in Megasquirt on, you want to make sure you have some settings that are going to be safe for your coil so you don't burn it up. Noise filter and rotary I'm not using. You'll notice a lot of these are grayed out, and that's because like if you go into noise filtering, you can probably turn on a curve and then that'll make that show up. So it's just trying to keep you from having to worry about all the settings that you don't use. So fuel table, I already have that open here on the right. I'm kind of prepping for my next video. I'm about to go shoot, driving the car and tuning a little bit. So this is the 3D view of the tool of the fuel map. And you can see this would be, let me switch on over to the 2D mode to explain this. So fuel load here, which at least for speed density tuning is going to be your manifold pressure. So 100 right around this line here, right here and below, is going to be all your naturally aspirated areas of the pressure map. Up here is your boost, and so what this does, it'll continue on forever at 101 here on up and so on. But this is going to be your volumetric efficiency table. So if you come back and look at this required fuel, actually I skipped over explaining exactly what that is. What it is, or my understanding of what it is, I could be a little off, but basically this is the amount of fuel it takes at 100% volumetric efficiency for your engine to do a complete perfect cycle. So you're not going to run it 100% though. Nobody really does, or I guess you get into the turbo stuff and say maybe you'd run it more than 100%. But either way, 100% efficiency here. Changing this value is going to offset this table up or down. And so you want to make sure that you get this value right, because if you're using something like Simtech Labs MSQ file, the tune file, they may have 300cc injectors and you may have 500cc injectors. So this value is what makes this table in its current form work, is offsetting it globally. So what this is saying is 86, so I could actually take that up to 255, but I'll leave that back at 86. So if you take 86 over 255, you get about 33%. So multiply that by the 3.7 milliseconds of fuel, and I'm at about 1.24 milliseconds. So I'm using 33% or so of my fuel headroom, I would call it, at this part of the table. So that part of the table corresponds, I was somewhere around here, or 86, okay. So that's 120 kPa. So boost threshold is right here. So I'm a little bit into boost, and actually if you look up here at 129, assuming this table is calibrated all the way at 700 or 7500 RPM, and this would be around 15 psi of boost, I'm using 128 out of 255 so that would be about half of my fuel headroom. So part of that's because I'm running higher pressure, part of that's because I'm running pretty large 560cc injectors. Some guys will go with 1000cc injectors, which is fine, or even 2000 on some of the crazy builds. But go back and watch my high versus low impedance injector video, and I'll talk a little bit about why you don't want to just go for 1000 or 2000 necessarily. A lot of the modern injectors are working pretty well, I think. I don't have any personal experience with them, but from what I've read about it, the modern injectors you can actually idle with a 1000cc injector, but I guess back in the olden days maybe they weren't as good, and so you lose a lot of that fine resolution down low that you really need to keep a good idle. So if it's a race car and you don't care much about idle, then 1000 for sure. But that's sort of the point of going with these kind of middle of the road. You calculate what you need and use that so that you get maximum resolution over the area that you want to use. So the spark table that was down here in basic setting, ignition table. This is the ignition advance. You can see up here in boost, it's retarding quite a bit of timing, so that's going to keep it good and safe, keep it from detonating. This is one of the key things to making big power, is tuning these guys in just right at the edge of the knock limit. But since I don't have a knock sensor, and I'm not sure if I'm going to anytime soon, there is one on the engine, but I need some conditioning circuitry or something. So I've yet to really look into doing that, because I've got forged pistons for one thing. Doesn't mean you can ignore the timing table necessarily, but I'm also running factory wastegate pressure at 8 psi. So I'm not really going to get crazy on this thing, and I feel like the stock boost or timing table should be good. So if I build some deck cans, or if I get an actual knock sensor brought into Megasquirt, I'll start tuning that, and I'll definitely do videos on that if I do that. But moving on, we got the AFR table here. This is the AFR target table, basically. So you set where you want to be at certain points in the process. So this is 13.1. 15 would be down in the cruise area here, on into the higher RPMs. It's just, this is not real standard cruising down the highway RPMs right here. So it's getting a little bit richer. And what this is used for is your EGO correction here. I actually have mine turned off because I'm tuning and I don't really want it messing with stuff. And really, I don't care so much about this AFR table. I'd rather kind of do it myself and feel it out. But what you can do, auto-tune's going to use this table. If you auto-tune, and it's going to try to tweak your fueling, which would be this table here. It's going to trim this fueling to match this AFR. And the auto-tune does a good job at trying to take out all the transient stuff, and anytime things are changing really quickly. So if you are doing auto tune, make sure that you try to keep your car in nice steady states and things like that. So that way it's got a chance to correct. And you can define, I'm not going to talk about auto tuning much because it's pretty easy, but you define the amount of authority that the algorithm has over your table, so it can tweak it real fine, but it won't make any big adjustments, stuff like that. So got some more general settings here. This is kind of filters of the inputs, which basic stock settings should be fine unless you have trouble anywhere. This is how you're going to do rev limiting. Soft rev limit 5500. I think I've got that set a little bit artificially low, but I'm going to leave it now. I don't need to be revving the heck out of this engine right now. I should do 7000 just fine, but anyway, EGO control I think I might have just shown, but yeah, you can tell it what kind of wideband you have or narrow band, and it'll adjust your fueling. So it's kind of nice to do that, because if you have different quality of fuel or stuff like that, it's gonna try to dial it in. It's more like a modern car would do. Well, I say modern, even my Camaro does that with trim tables and stuff. So that's pretty nice. Cranking settings, RPM this is how it senses whether you're cranking or not, cranking the engine over. Priming pulse is right when you key on, it's going to give you a certain amount of fuel in there. I've heard this is actually just to get air out of the lines, but it does put some into the cylinders for cranking. Priming pulse and cranking pulse width, so this is how much fuel you're getting during cranking. So you just kind of want to tweak those or use the values that are in the MSQ that you already got. They're usually pretty good. ASE, acceleration enrichment, after start enrichment. This is not acceleration. This is after start. So it's gonna keep your fuel extra trimmed up high until you get up to operating temperature. So the hotter it gets, the less compensation you're going to end up with. So I'm actually a little bit curious why I have after start enrichment up there, but I'll check into that later. Here's your taper, more after start enrichment, and closed loop idle valve is what I'm using. I'm not going to go into those settings. I'll talk about those in the idle video. And warm up enrichment is while you're getting warm. It gives you. Oh, I'm sorry. So I screwed that up. After start enrichment actually is just for, I believe, the amount of it's how much time it keeps richening it after you start it, and it goes away pretty quick. Whereas warm up enrichment is as your car, I'm really, really cold, it's going to want a ton of extra fuel, like almost double fuel here. Of course, it never gets that cold where I live, but around here, this will help you keep a nice smooth idle while it's warming up. So it's kind of a cool thing to tune up. There is a warm up enrichment. Let's see if it's on this version. No, it's not. There is a warm-up enrichment wizard, actually. Oh, here, no, acceleration wizard. There is a warm-up enrichment wizard in the newest version of Tuner Studio that I've yet to try. But Excel settings. So this is like really, if you really stab the throttle real quick, the VE table here, the volumetric efficiency table, won't necessarily have time to react and give the proper amount of fuel. So when it sees a very sharp change in throttle position, they call that TPS DOT, TPS dot. I think that's like degree of change or derivative over time or something like that. But either way, it's how fast it's changing, not its current value. So when it sees a big change in throttle position, it will throw a bit of extra fuel in there to make sure you don't have a lean spike in there. So programmable on and off outputs. I haven't actually showed this. I shot a video and it was horrible. It just didn't go well. I'm using my F idle pin to turn on coolant, or rather turn on the cooling fans. And if I go over 185 with some hysteresis in there, I will turn on that fan. And I also do if TPS is less than 95. I assume if I'm above 95 percent throttle that I'm at least cruising down the road and getting tons of airflow over my radiator, and it's kind of just a because I can thing. I thought it was kind of cool because it'll cut the fan and relax your alternator just a bit for max power. It's probably doesn't make much of a difference, but let me do it, so I did it. Barometric correction. This is going to use your map right off the bat before you start the engine and record the atmospheric pressure, and then it will make a correction for that as well. So that's kind of cool. Once your engine, it's assuming you're not doing huge elevation changes, although you can also use barometric correction in real time if you want, if you have a second map sensor that's open to the atmosphere. So cold advance, similar to warm-up enrichment, I believe, although I'm not using it. Correction table, flex fuel stuff. This is under the extended menu, so some of this knock sensor settings, overrun fuel cuts when you let off the gas, and it knows that that the motor's kind of being pushed by the car, like you let off the gas but you haven't pushed the clutch in, and it will cut all the fuel and just let the motor kind of free run. So staged injection is if you say you have nitrous and you want a wet system. It's probably a bad example because there's a whole nitrous setup as well here, but stage injection, if you have a second set of injectors, maybe you've got some 200 cc's to idle with, and then you've got some 2000 cc's that once you're above idle they kick in and start going. So you can set all that stuff up in here. It's pretty awesome. TAC output I'm not using, but I need to be because my stock TAC is not working right now. I got to wire that in though. Launch control is awesome. It'll hold a RPM until you let off the clutch. It uses the clutch signal as an input. Table switching you can use for flex fuel sort of, or you can say have a teenager map, or you can do also whatever you want to do. A lot of people use this to double the resolution of their table, so they'll have like this fuel table. Pretend there's just off the top here, there's a whole nother table this same size, um, and you can switch on different conditions. So you'd say, when the map passes this threshold, switch to the other table. But that's more advanced than I wanted to get right away. Nitrous overboost protection, idle advance. Idle advance can be helpful to, instead of using your IAC valve, it'll change your time, or in combination with maybe it'll change your timing to keep an idle good and steady with changing loads. So that's helpful when your air conditioner kicks on and stuff like that. So dwell battery correction, so that's your spark dwell is corrected with your battery voltage. Boost control, I'm not doing this yet. I'd love to, but we'll get into that later. CAN parameters, if you want some expansion stuff over CAN bus. Experimental test modes, MAF, sequential injection, tuning, real-time display. There's some other sort of tuning displays here that are kind of integrated. I just sort of made my own here. Histogram I haven't played with much, but anyway, so that's sort of the tour. And you got auto tune is here up at the top. It will do stuff for you, but I'm going to stay out of that for now. And that's about it. So assuming everything went well with my recording, I'm going to jump into the car and go drive around and do a little bit of tuning. And maybe if I have time, I'll do the idle tuning video as well. So stay tuned and check those out soon. Subscribe if you like these videos, and hopefully I'll have some more on the way.